Hello, everyone. Come on. Some love, please. If you look at my last name, you might think I'm German. I'm actually not. I'm originally from Paraguay. And before starting this, I wanted to ask you if you know what is the biggest, the greatest contribution of Paraguay to hacking. Anybody? You will never guess. So let me just show you what it is. It's actually right here. Mate is actually from Paraguay, so you're welcome. Thank you, you're welcome. So my talk is called CookieMonstruo, Hijacking the Social Login. As I was introduced, I work as a pen tester, but apart from doing that, I also enjoy a lot giving presentations to not the kind of people that you are, but people who are not very aware of IT security. I enjoy that very much. And more often than not, I get asked the following question when I'm doing this type of presentations. That is, can you hack my Facebook, Gmail, Outlook, whatever? I'm sure most of you can relate with these type of questions if you tell them you work in IT security. So if I had a dime every time I got asked this question, then I would be a very, very rich person. So one day I decided, you know what, I'm gonna try to figure out how to do this. I guess I was tired of giving the same vague answers to these people all the time. So I sat down, I started to think, okay, how am I gonna approach this issue? And the first thing you might think of is probably go for phishing, do some credential harvesting, maybe install a keylogger in your victim's machine, maybe grab the password from the browser storage or the password manager. If you know some forensics, you might find in a memory dump, or maybe just do plain old guessing, right? But nowadays, security in web applications is getting better, and people are being more aware of the things that hackers are able to do. So more often than not, you're gonna be facing this little obstacle, which is called two-factor authentication. Since I had to deal with this when giving the answers how I will approach this hacking your web application account, and I didn't want to tell them that, okay, let's just go for some social engineering techniques to try to grab your two-factor token. I need to find something better, something more simpler and effective. So then it came to me that how about cookies? And I'm sure most of you are aware of what cookies are, I hope. But for those of you who are not, who don't know what they are, and also for those of you at home watching, let me give you the cookies 101. So the web browser authenticates to a website. You send your username and your password, then you send the two-factor authentication token, and then the website will validate your authentication mechanism and will send back a token, a cookie to the browser, basically just a long random string that will, in essence, become the password or the credentials that your browser will use to the web application for the duration of that session. Now, let's focus on the fact that the authentication part happens here, and that includes the two-factor part of the authentication. And the cookie is only generated after all of that has already been validated. So that gives you a hint that if you somehow manage to grab the cookie from your victim, then you most likely will be able to bypass most two-factor authentications protections being in use nowadays. So how do you do cookie stealing? So if you want to know how to do cookie stealing, you'll probably go to Google and do a search, how do I do cookie stealing? So the first 1 or 2 pages, which is pretty much all that exists, who goes to the third page in Google, they will tell you something that can be briefly summarized in this little snippet that I have here. So let's read it. An attacker can use a variety of methods in order to steal your Facebook authentication cookies depending upon the network that he's on, blah, blah, blah. So, and the only mechanism protection against this, the only way to do it is to use encryption, HTTPS. So it was very surprising for me to see that most literature on the web only talk about cookie stealing as a network-based attack. But what about the jar? So this obsession with network-based cookie stealing and session hijacking attacks means that people forgot somehow that cookies not only live on the network, on the traffic, but they're also stored locally by each browser. So here we can see an example from Google. That's the cookies file, which is located somewhere in your user folder on Windows, which is just basically an SQLite database that contains all your cookies. And here we'll have the same example with Firefox. Again, SQLite file somewhere in your users folder. The same principle. So let's take a closer look. So this is the Firefox table, the database, and the most cookies that contains the cookies information. Very straightforward. You just have a table that has all the cookies here with different properties and the values of the cookies here. So that's great. That means that if you manage somehow to gain access to the file system of your victim, then you can easily steal their cookies because they're just lying there. Now, let's go to Chrome now, and we can see that they're doing actually something more about protecting these cookies. So if you see the value column here, you will notice that it's used most of the time. You'll find it empty. And if you take a look to the right, you will see there is another column called encrypted value. So Chrome goes, like I said, a bit further with protecting your cookies, and they're actually encrypted. But at least for Windows, what they use is a key that is associated with the Windows profile of the user that owns that cookie. So that means that if you are able to run code within the same context of the user that owns that cookie, then you are also able to decrypt that cookie. So the fact that this attack vector has largely been ignored by most of at least the offensive security people, means that at least up to my knowledge, there was not a good tool developed to help you retrieving these values from the file system. So since I couldn't find a tool, then I just said, well, why don't I just make a tool? So that's why I started developing CookieMonstruo. So what's CookieMonstruo? Just a simple PowerShell post exploitation script. So it means that you have to compromise your victim's machine, obviously. Why do we need this? Well, to help an attacker, or a tester, obviously, quickly dump the local cookie storage and identify active sessions. So the tool should support different browsers, and at the moment supporting Chrome and Firefox on Windows, of course. Should also be able to target popular web applications such as Facebook, Gmail, Outlook, Twitter, or the big ones. And also should be able to target custom-defined session tokens, which I'm still working on. So let's just have a brief demo time so you can see how the tool works. So let's hope this time it doesn't screw up. So here we just have, so this is a Windows machine that's been compromised already. The file system is compromised. So let's log in into this Facebook application. As you can see, two-factor authentication is enabled. So as if you want to remember the browser, believe me, this doesn't matter. You can choose either option here. So as you can see, we have a valid session now with Facebook. And we're coming from this IP. You can see there it starts with the 1A1. So now let's go to my command and control machine, which is located somewhere in the cloud. It's running Empire. If you heard of Empire PowerShell framework. It's a really cool framework for using PowerShell to hack computers. So this PowerShell agent, which is already running on the infected machine, has already the CookieMonstruo script loaded. And what we're going to do is just run it. It might be a little hard to read, but it just says, invoke CookieMonstruo. We're targeting specifically Facebook in this case, and we want to make the output of the tool exportable so that we can use it later to load it in our local machine. So this will be the output of the tool. It will just tell you the cookies that you're interested in, the ones that are using to handle the session part of Facebook, and it will give you a nice script that you can run locally on your machine to create a cookies file that you can later load into your attacking browser. So let's see this in action. We're just going to copy that little script from the command and control server. We're going to run it locally in our machine. So we created this cookie file. Now I'm gonna go into VPN, so I change the IP that I'm coming from, so you can see that the IP doesn't matter in this case. So as you can see, I'm coming from a completely different IP, which is located in a different country. I'm gonna load here the cookies with this Firefox extension for handling cookies. And just gonna go to Facebook, and as you can see, the session hijacking it's achieved, despite the fact that we're coming from a complete different operating system. As you can see, this is Mac, the other one was Windows. Completely different browser, Firefox as opposed to Chrome, and a completely different IP in different countries. Yeah, so that's pretty much it. Very simple. So not everything is unicorns and rainbows when it comes to cookie stealing. There is some other stuff that you should consider as well. So sometimes the victim just doesn't have an active session to the whatever application you're targeting. So what can we do in this case? Well, if you have access to the file system and that computer is used by the victim to log into that specific website that you're interested in, it's very easy to just sit and wait, basically, right? So that's what I have implemented in the tool. It's called Wait and Steal. It's just you check every n amount of time until you see that the cookie database contains the cookie that you're interested in. When that happens, the cookie that you're interested in is retrieved. Very simple, very straightforward. Another thing that could happen is that the user, the victim, can invalidate the session that you have stolen by logging out. So you can think when you retrieve the cookie from the victim, both the victim and the attacker will be in possession of the same cookie, two copies of the same cookie. So what can we do in this case? Well, very simple. We just use a thing called remove cookie, which will basically just delete the cookie from the database of the user, and as an attacker, you will be the only one holding that copy of the cookie. So this actually has some serious implications, at least for the case of Facebook and all the mainstream applications. They do some good session management. They allow you to end sessions manually if you don't trust those active sessions. But you can think of applications that you might develop or that you might test if you're a tester, which don't have these session management controls. So if I steal a cookie from you that has an active session to a web application that is important to you, and if you don't have access to that cookie anymore, how do you kick me out of your session? So that's something to think about. So another reason why I focus so much on these mainstream applications like Facebook, Google, and the others is that they are not only, when they handle authentication, they don't only handle their own authentication, but they also provide a thing called social logging. So I'm sure you're familiar with this. You maybe use it. How many of you use social logging to log in with your Facebook and Google accounts to other accounts? Don't be ashamed. I do it, and I wrote this. So I wrote this presentation. Anyways, so here are some examples. Now let me give you a little secret about social logins. You don't really need to know the username and password of the account that you're using your social login with in order to hijack the session of the application that relies on the identity provider in order to hijack the session. So if we have a look at this little graph here that explains a little bit how the flow typically looks in these implementations of social logins, we can see in step number 3 that if the cookie is available for the identity provider and you have a valid session, then automatically you will have a valid session with the other application that relies on the identity provider as an authentication provider. So let's see this in a little bit in a demo. See here. So very quickly, I'm just gonna log in to Google, two-factor authentication again, Twitter again, two-factor authentication enable, and Facebook, same thing, two-factor authentication enable on this victim machine. Yeah, so we have now a valid session with all these three sites. So this time we're gonna run CookieMonstruo, except we're not gonna target any specific application. We're just gonna dump the whole cookie database. Makes it easier. So here we have the entire cookie database for that particular user. Same process. We're gonna copy the little script. We're gonna put it on your local attacker machine, and we're gonna proceed to hijack the sessions. So here we're creating the cookie file in your local machine, and now we're going again to our attacker machine. We're gonna load the cookies. We're gonna change our IP so you can see that we're coming from a different place. So all this session hijacking thing is nothing new, by the way. This is a well-known issue, but a lot of people that I showed this to, they actually not aware that you can do this, and that is why one of the reasons why I decided to try to take this issue around and show it to people. So just how many of you know that you can do this? Okay, so you're aware of the issue, right? That's cool. So now we have the session hijack, and then now we're gonna take a look of the apps that are connected to this. So we go to Facebook, we go to the settings and apps, and we can see an example here, Expedia, that they allow for logging with Facebook. So for Gmail, we go to my account. We go to connected apps and sites, and as an example, we have right here Dropbox, which is connected to this account. And for Twitter, it was so hard to find an application that actually relies on Twitter, but I found one. MySpace. Yeah, I haven't used MySpace in so long. So let's go to Expedia now. Sign in with Facebook, and as you can see, now we have a valid session with Expedia as well, which is relying on Facebook as an authentication provider. So these are just examples. There's many other applications out there, and the security implications of this depend on what application we're talking about. Now let's go to Dropbox. Same thing. We can sign up. Well, not sign up in this case. This actually stands for sign in because the account already exists. And now we have also gain access to that Dropbox account. Now let's go to MySpace, and this is what MySpace looks like in 2017. So I always love all those cookie messages here because they go so well with the. Anyways, so same thing, Twitter in this case. And now we are logging again as the user. Yeah, so that's pretty much it. So of course this attack will not work, will not be effective at least on some web applications that implement strong session management controls such as short session expiration timeouts, not allowing concurrent sessions, binding session ID to other user properties, etc. Now the question is, how many of the mainstream applications or the applications that you develop or the applications that you test on your daily life actually implement all these controls? And it's a very hard thing to do because it's a very big question and a balance that you have to do between usability of your application and the security of your applications. So yeah, it's not an easy thing. So I've been in talk with Google. I wrote Google, Facebook, Twitter, and some others that I'm investigating as well to see what's their take on this. And basically, the answer can be summarized in this is beyond the control of what we can do, because once you lost control of your file system, then all bets are basically off. So there's not much that can be done about it, at least. Yeah. So as a conclusion to this, I want to say that most conventional knowledge will argue that using social logins is safer, as we tend to believe that the strong authentication controls that these identity providers implement will make our accounts more secure. Now, I really don't want to argue against that or for that, but I just want you guys to consider that this is a factor when you are deciding whether or not to sign up for social login providers. So before I finish, I just want to leave you with a final question that I asked myself. Is it okay to have lax session management practices on sites that are authentication providers? So I will leave that to you to answer yourself, and maybe we can have a discussion after. Anyways, but that's all for my presentation, at least. If you want a copy of the tool, is available on my GitHub at Claymore, so you can write me on Twitter as well there. And I presented this at BSidesMunich as well, but it was a 1 hour presentation back then, so I had a chance to do more demos, some cool things. So if you want to take a look, you're interested, you want to see more demos, then you can check out the cool Cooper's filming of BSidesMunich. Yeah. Anyway, that's all from me. Thank you very much.
Very interesting, Martin. Thank you. Questions?
Yes.
Gmail sends out
Nice.
an email when you're logging in from a different device.
Yes.
Does it happen only at the login time?
Yes. Most of the controls, including the Gmail control and the Facebook controls, are only done at authentication, at least from my experience. Maybe Mike, you can, if you know more about this. So you're the Google guy here.
Yeah, because he talked about secure cookies this
exactly.
morning as well. So,
but that was from a different perspective.
True.
Anyway, so most of those controls, at least from what I've seen and what I was doing the testing, is only happening during the login. So that's why I wanted to emphasize, if you're coming from different IPs, at least Facebook and Gmail are not complaining so much, and they only complain when you do the authentication, and that's where most of the checks are done. At least from my experience. So if you have experienced something different, then I would be very interested in seeing that.
But they could at least do user agent comparison.
Well, that's exactly what I asked when I was talking to them, and they told me that they didn't think that was the right way to go about it, to do any property bindings to the cookies. They didn't think that was an effective solution. I don't know why. I'm not gonna say why they think that. That's just what the answer that I got from them. I think it has to do a lot with usability, because you don't want your session to break every time you change IPs. Like if you have a mobile
Yeah, with the IP, I can get that. But the user agent's different. Yeah.
Just the user agent doesn't change if you change your IP.
He gave me a reason, but I can't remember right now.
The operating system,
if you upgrade the browser.
The thing is that you can also spoof those. So at the end of the day, is it really a protection? I mean, it will hire a little bit the security, but it's not really a solution. So. Yeah.
Okay, so what's your recommendation then for users?
Well, yeah, actually one thing that I seen work in this case, if you're really paranoid, you might want to browse in, only use the internet on, what is it?
Safe browsing.
Incognito mode, that's it. Because incognito mode doesn't flash the cookies to the hard drive. It only keeps them in the memory from what I've seen. So at least until I figure out how to extract them from memory, you're safe. Yeah. So that's a little thing that you can do. But otherwise, just don't have your computer hacked, basically.
Thanks, that's a very good piece of advice. Thank you.
I don't actually know. I would assume it deleted from this, but for Firefox, there's a add-on that I like to use, which is the cookie auto-destruct, which you can set to either never delete the cookie automatically, delete it when I close the browser, or delete it when I close the app.
So that's a good approach, but the thing is, like you saw there, one of the things that the tool implements is that it waits until it sees that it's a cookie with an active session, and it will just steal it. So that will not really protect you. So what the tool will do is it will just constantly check, and when it sees that you log on to that site that I'm interested in, it will actually first it will have to crash the process of the browser in order for me to be able to delete it from the cookie, because the browser has a lock on the cookie database. So what I do is I crash the browser process. I retrieve the cookie, I delete it, and then you can log in again. So I have another session to your. So with, like I said, with Facebook.
Still active on the website.
Yeah. So at least with Facebook and Google and the big ones, you can still go there and manually delete the other session if you actually realize that you can hack. But there's many other websites out there that don't have this control. So that's why it's an interesting thing to think about.
Okay, let's call it break time now. Just 5 minutes so you can have a cup of coffee. Not that it's a real coffee break yet. That comes a little bit later, but just because we have 5 sessions in a row. And then if you want to keep discussing with Martin, we've got the breakout session in the back. That's cool with you, Martin?
Yes, no problem. Thanks.
Thank you.